So next one, electrical comparators. Okay, here these are all the following contents: electrical comparator, working principle of electrical comparator, working of LVDT, and advantages and disadvantages. So what is electrical comparator? Electrical comparator which converts the plunger movement, so which converts plunger movement into electrical signal. Now let us discuss the working principle of electrical comparator. The electrical comparator uses Wheatstone bridge. So Wheatstone bridge consists of 4 resistors R1, R2, R3, R4. We know the balancing condition of Wheatstone bridge, that is the ratio of R1 by R2 which is equal to R3 by R4. When this condition is satisfied, the bridge is said to be balanced. When the bridge is balanced, okay, here there is no flow of current through the galvanometer. So this is galvanometer. So this is galvanometer. Okay, here there is no flow of current. Okay, here. So this is galvanometer. When the bridge is balanced, so then there is no flow of current through the galvanometer, and hence this pointer shows 0 reading. When the bridge is unbalanced, then so okay, here current is flowing through the galvanometer, and hence pointer moves on the scale. This is all about Wheatstone bridge. Wheatstone bridge consists of 4 resistors R1, R2, R3, R4. So this is the condition for balancing of Wheatstone bridge. So when the Wheatstone bridge is balanced, there is no flow of current through the galvanometer, and galvanometer shows 0 reading. When the Wheatstone bridge is unbalanced, okay, here current is flowing through the galvanometer, and then we can observe the movement of pointer in the galvanometer. Now, coming to this diagram. Okay, here this diagram shows the working principle of electrical comparator. Okay, here we have an armature. Armature is nothing but iron rod. This iron rod is kept between 2 coils A and B. This armature is supported by using thin steel strip, just like a cantilever structure. And this is the plunger. Now, so first place the standard below the plunger. First place the standard below this plunger. Now, okay, here, so we can observe from the diagram, okay, here when there is no movement of the plunger, okay, here the distance of armature from 2 coil will be same. When the distance of armature from 2 coil is same, the Wheatstone bridge is said to be balanced. Now the standard is taken out and component to be inspected is placed below this plunger. Now, so when the dimensional difference, if there is any dimensional difference between standard and workpiece, suppose if workpiece dimension is greater than standard, or suppose if workpiece dimension is lesser than standard, so then we can observe the movement of the plunger. So plunger movement takes place only when the dimension, if there is any dimension between standard and workpiece, suppose if dimension is greater than standard or if dimension is lesser than standard, so then only we can observe the movement of the plunger. Okay, here I have placed the workpiece or component to be inspected. If there is any dimensional difference, plunger movement takes place. So when the plunger movement takes place, okay, here armature get tilted. Due to this distance, the distance get changed or distance is varied. So when this distance is varied, when the distance of armature from 2 coil is varied, so the Wheatstone bridge is unbalanced. When the bridge is unbalanced, already I told you, current is flowing through the galvanometer. So when the bridge is unbalanced, so current flowing through the galvanometer, and hence we can observe the movement of pointer on the scale. Suppose, assume that if the dimensional difference, if there is no any dimensional difference, that means the standard, the component, so having exact dimension with respect to standard, if there is no any dimensional difference, so both are same, if standard and workpiece are same, so then there is no movement of the plunger. There is no movement of the plunger, therefore the armature remains stationary. There is no movement of the armature, therefore there is no varying of distance. Therefore the bridge is balanced. When the bridge is balanced, there is no flow of current. That hence, so there is no movement of the pointer in the galvanometer. When there is only dimensional difference, so when there is any dimensional difference, plunger movement takes place. Next, armature movement. So next, the bridge get unbalanced. When the bridge unbalanced, we can observe the movement of pointer on the scale. This movement of the pointer on the scale corresponds to the dimensional difference. The movement of the pointer on the scale corresponds to the dimensional difference between standard and workpiece. So this is about the working principle of electrical comparator. Once again, Once again I will repeat. So first, so for the plunger or for the standard, so there is no moment of the plunger. Therefore, there is no moment of the armature. The bridge is balanced. Now, the standard is taken out and workpiece is placed. If there is any dimensional difference, the plunger moment takes place, armature moment takes place. Therefore, the bridge get unbalanced. Therefore, you can observe the moment of pointer on the scale. So, if there is no any dimensional difference, then the bridge will be balanced, and okay, here there is no moment of the pointer on the scale. So, this is the working principle of electrical comparator. So, next let us discuss the construction and working of LVDT. LVDT is an example for electrical comparator. LVDT, linear variable differential transformer. LVDT is an example for electrical comparator. So next let us discuss the construction and working of LVDT. So next let us discuss the working of linear variable differential transformer, that is LVDT. LVDT is the most popular electromechanical device which converts displacement into voltage. Now let us discuss the construction of LVDT. This figure shows the construction of LVDT and this figure shows the LVDT circuit. In the construction, okay, here we have hollow cylindrical tube. So this is the hollow cylindrical tube. Next, okay, here primary coil, this is primary coil is placed at the center of the tube. Primary coil is placed at the center of the tube and this primary coil is connected to AC source. Then two secondary coils, secondary coil 1 and secondary coil 2 are placed at the side of the tube. Next, the number of turns in the secondary coils are equal. Say example, if secondary coil 1 consists of 100 turns, then the S2, it should also consists of 100 turns. So 100 means the number of turns in the secondary coil S1 and S2 are same. Next, the secondary coils are wound in opposite direction. That means, okay, here secondary coil 1 is wound in clockwise direction, secondary coil 2 is wound in opposite direction, means anti-clockwise direction. That's why, okay, here the output voltage is E1 minus E2. Since the two secondary coils are wound in opposite direction, the output voltage will be the difference between S1 and S2, means the voltage induced in S1 and S2. Next, we have an armature core which is placed in the inside the tube, and this is the movable armature core which moves inside the tube. Next, its armature core is connected to arm. Then here input is the displacement. This is about the construction feature. So once again I will repeat, okay, here we have hollow cylindrical tube. Inside the hollow cylindrical tube you have an movable iron core. This movable iron core is connected to arm. Next, here we have at the center of the tube we have primary coil. This primary coil is connected to AC source. Then two secondary coils are placed at the side of the tube. The number of turns in secondary coil 1 is equal to secondary coil 2. Next, so the two secondary coils are wound in opposite direction, means if S1 is wound in clockwise direction, then S2 must be wounded in opposite direction, means anti-clockwise direction. Now, so this is the LVDT circuit. Okay, this construction is schematically represented by this diagram. Okay, here already I told you we have an movable iron core. This iron core connected with arm. The input is the displacement. Next, we have primary coil at the center of the tube. This primary coil is connected to AC source. Then here we have two secondary coils. So S1 and S2. The voltage induced in S2 it is denoted by E2. The voltage induced in S1 is denoted by E1. The number of turns in S1 means S2 which is equal to S1. The two secondary coils consists of equal number of turns. Next, the two secondary coils are wound in opposite direction or wrapped in opposite direction. That's why output voltage will be difference between E1 minus E2. So this is about the construction features of LVDT. So next, so let us discuss the working of LVDT. Now, okay, here, so through the arm, I am going to give the displacement. Now, when there is no displacement, assume that when there is no displacement, this armature core exactly at the center of the tube. Armature core lies at exactly at the center of the tube. When the armature core lies at exactly center of the tube, or when the armature core is in the center of the tube, okay, here the voltage induced in the secondary coils are equal. Okay, here when the armature core moves inside the tube, here we have a displacement. Next, let us discuss the working of LVDT. Okay, here as the armature core moves inside the tube, because of mutual inductance, voltage induced in secondary coil 1 and secondary coil 2. When the core moves inside the tube, voltage induced in S1 and as well as S2. Now, so when the core is in the exactly at the center of the tube, equal amount of voltage induced in S1 and S2. But the output voltage will be the difference between S1 and S2 because these two coils are wound in opposite direction. Output voltage is E1 minus E2. When the armature core is at exactly at center of the tube, okay, say example, okay, here 5 volt is induced, okay, here also 5 volt is induced when the core exactly at the center of the tube, right? So when the core moves inside the tube, because of mutual inductance, some amount of voltage induced in S2 and some amount of voltage induced in S1. When the core lies exactly at the center of the tube, equal amount of voltage induced in S2 and S1. Now, what is the output voltage? Output voltage will be the difference between E1 minus E2. Why it should be the difference? Because the two coils are wound in reverse direction, are connected in reverse direction. These two coils are connected in reverse direction. That's why E0 which is equal to E1 minus E2. Suppose when the core moves towards left side, then here more amount of voltage induced in S2 compared to S1. When the core moves towards left side, so okay, here because of magnetic coupling, so okay, here more amount of voltage in S2 compared to S1. Then what is the output voltage? Output voltage will be the difference between, so E1 minus E2, that is 15 minus 5, 10. Suppose if core moves towards right side, okay, here, so the maximum means more amount of voltage induced in S1 and compared to S4, that is 15 voltage induced in S1 and compared to S2. Then what is the output voltage? Okay, output voltage will be the difference between S1, E1 minus E2. So this is the working of LVDT. So in this diagram we can understand the working of LVDT. The working of LVDT can be divided into 3 cases based on the position of armature. Okay, here this is called null position. In the null position, armature is at the center of the tube. In the right position, okay, here armature moves towards right side. Okay, here in this position armature moves towards left side. Now let us understand the working. Okay, here in the null position, okay, here this is the secondary coil 2, this is the secondary coil 1 and this is primary coil. This primary coil is connected to AC source. Now, when the armature core is at the center of the tube, okay, here equal amount of voltage induced in S1 and S2 due to mutual inductance. Already I told you. So, okay, here due to mutual inductance, voltage induced in secondary coil 1 and secondary coil 2. S1 is the secondary coil 1 and S2 is the secondary coil 2. The voltage induced in secondary coil 1, it is denoted by E1. The voltage induced in secondary coil 2, it is denoted by E2. Now, when the core is at the center of the tube, then equal amount of voltage induced in coil 1 and coil 2. Therefore, output voltage E0 is given by differential voltage E1 minus E2. So, why we are taking differential voltage? Because the two coils are connected in reverse direction. So, okay, here secondary coil 1, so it is wound in clockwise direction, it is wound in anti-clockwise direction. Therefore, the output voltage will be the difference of E1 minus E2. Now, already I told you, when the armature is at the center of the tube, equal amount of voltage induced in coil 1 and coil 2. Say example, okay, here 5 volt induced in S1 and 5 volt induced in S2, then what is the differential voltage? E1 minus E2, which is equal to 0 voltage, because okay, here E1 which is equal to E2. Therefore, we are getting 0 voltage. And this condition is represented in this graph, displacement voltage graph. This is the x-axis is displacement and y-axis is the voltage. This origin represents the null position of armature. At the null position, we are getting 0 voltage and it is indicated at point 2 or origin. Now, let us come to second diagram. In this diagram, armature moves towards right side. Armature moves towards right side. Okay, here armature is moving inside the tube like this. Now, okay, here armature moves towards right side. That means, okay, here armature is close to secondary coil 1. Secondary coil 1. Now, output voltage is given by E naught, which is equal to E1 minus E2. Now, so when the armature moves towards right side, okay, here voltage induced in coil 1 is greater than voltage induced in coil 2. Say example, okay, here 15 voltage is induced in coil 1, but here only 5 voltage is induced in coil 1, coil 2. Because of maximum contact, because of maximum contact with S1, that means when armature moves towards right side, okay, here, so magnetic coupling is more between armature and S1. That's why here more amount of voltage is induced in S1. So when the armature moves towards right side, okay, here the voltage induced in coil 1 is greater than coil 2. Therefore, E1 minus E2, okay, here where E1 is greater than E2. So E1 greater than E2 because of right side position. Now, so and this condition, okay, here E1 greater than E2, therefore here we are getting positive voltage and it is represented by this one. Okay, here displacement is positive. The right side position considered as positive and here we will get the positive voltage because E1 greater than E2. Now, coming for left position, when armature core moves towards left position, then the voltage induced in coil 2 means S2 is greater than S1. Here more voltage is induced. Say example 15 volt. Here less voltage is induced because of left side position of armature. Now output voltage is given by E naught, which is equal to E1 minus E2, where E2 greater than E1. Therefore here we will get, so E naught which is equal to negative. Okay, here E naught which is equal to positive. Here E naught which is equal to, so negative. Why output voltage is negative? Because, okay, here armature core moves towards left side. Therefore, more magnetic coupling between armature and S2. Therefore, here more amount of voltage is induced compared to S1. And output voltage is given E1 minus E2, where E2 is greater than E1, and here we are getting negative voltage. And it is represented like this. Okay, here since we are getting negative voltage, so and this portion represents the left side position. Okay, here this graph represents the left side position and this graph represents the right side position, and origin represents the null position of armature core. So this is the working of LVDT. So remember, when the armature at the null position, we are getting 0 voltage. When the armature at the right side, more amount of voltage induced in secondary coil 1 than S2. Then when armature core at the left side, more amount of voltage induced in S2 than S1. Therefore, E2 greater than E1. So, okay, here this line represents the left side position and this line represents the right side position. This origin represents the null position. So, this origin represents the null position, and here, so this is right side position and this is left side position. So this is the working of LVDT. Next, let us discuss the advantages, disadvantages and applications of LVDT. So next, let us discuss some advantages and disadvantages of electrical comparators or advantages and disadvantages of LVDT. So these are all some advantages and disadvantages of electrical comparator. Okay, here advantages of electrical comparator like high magnification. less friction and low power consumption, small and compact and easy to operate. These are all some advantages of electrical comparator or advantages of LVDT. Then coming to disadvantages of electrical comparator or disadvantages of LVDT, it requires external power supply to operate. Next one. So, then coming to disadvantages of electrical comparators or disadvantages of LVDT. Okay, here it requires external power supply. Next, more expensive compared to mechanical comparators. Then variations in voltage or fluctuation in voltage, it may affect the result. So these are some few disadvantages associated with electrical comparators. And coming to applications of LVDT, LVDTs are mainly used to measure the mechanical displacement in the range of fraction of millimeters to centimeter, and LVDT also used to measure the pressure, force, weight, etc. So these are all some advantages and disadvantages of electrical comparators or LVDT. Okay, welcome back. So in the last class, we have discussed about electrical comparator, and in this session, we will discuss about electronic comparator. So electrical comparator which converts the plunger movement into electrical signal. Okay, here this block diagram shows electronic comparator. Here we have transducer which is connected to plunger. Then here we have oscillator, amplifier, demodulator, and pointer and scale arrangement. Now, this transducer converts linear movement of plunger into electrical signal. This transducer converts one form of energy into another. Okay, here this transducer takes the linear movement of plunger into electrical signal. Now, the oscillator takes the electrical signal and it produces periodic oscillating electrical signal. This periodic oscillating electrical signal, so it has small strength and it needs to be amplified. Okay, and hence here amplifier is used in order to increase the strength of the signal. Now, this amplifier converts small AC signal into large AC signal. Next, the demodulator. Okay, here demodulator is required to obtain DC output. Now, this demodulator takes the large AC signal from the amplifier and it converts into direct current. This direct current drives the pointer on the scale, and hence here pointer moves on the scale and it shows the dimensional difference between standard and workpiece. So this is about the construction. Now let us discuss the working of electronic comparator. Okay, here before placing the component to be checked, first place the standard. Okay, here first place the standard below this plunger. Now set that pointer to 0. Okay, here set this pointer to 0. Next, standard is taken out, then component is placed below this plunger. Suppose if there is no any dimensional difference between standard and component, means if component and standard dimensions are same, then okay, here we can observe that there is no movement of pointer. Means pointer it shows 0 reading only because same dimensions of standard and component. Suppose if component dimension is different from the standard, suppose if the dimensional, if we have any dimensional variation with respect to standard, then we can observe the plunger movement. Okay, here if we have dimensional difference, then we have plunger movement. Plunger moves upwards or downwards. This linear movement of plunger is picked up by transducer. So transducer it takes the linear movement and it converts the electrical, so transducer converts the linear movement into electrical signal. Now this electrical signal is fed to oscillator. So the function of oscillator is to produce periodic oscillating waves. Now this periodic oscillating wave, okay, here it has small strength. So we need to amplify the strength of the signal. For that purpose we are using amplifier. Amplifier converts small AC signal into large AC signal. So next, the demodulator is used to obtain DC output. So finally, the demodulator converts the AC input to DC output. So this DC output drives the pointer. So finally, the movement of pointer, we can observe the movement of pointer on the scale. The movement of the pointer on the scale corresponds to the dimensional difference between standard and workpiece. So this is all about the electronic comparator.